Could be the squeaky wheel. I thought I was a squeaky wheel.
All right. So we're here with the minds behind SQL Everywhere. And introduce yourselves. Who are you guys?
I'm Steve Lasker, a program manager in the Visual Studio team and the UIFX team. And we've been working on kind of enabling these occasionally connected clients for a while.
Yeah, I'm Anil Nori. I'm an architect in the SQL Server group.
Okay.
I've been working in databases for a long time, and I've done a lot of applications also. Mm-hmm. And that's what led me to the kind of applications and the kind of changes that are happening in applications drove us to really look at something like SQL Server Everywhere technologies.
Excellent.
Hi, I'm Carlton. I'm a developer from the RAD data team in Visual Studio. I did a lot of the RAD data experience for Visual Studio 2003, mm-hmm. and I'm continuing along that chain for 2005.
Excellent. So
Carlton's the one that actually made everything work in Visual Studio for 2005 for all the data scenarios we do with SQL Server Everywhere. So
nice job, man.
Yeah, it was a lot of fun. It was a lot of fun working with Steve. We got to take all the desktop experiences and bring them down to the device. And the device is a cool platform, but it's really great to see SQL Server Everywhere come into the desktop.
Excellent. So what is SQL Server Everywhere? What are we solving here? What's the problem?
Well, actually, to Anil, is kind of we've been driving it, but Anil actually owns a lot of the SQL Server Everywhere long-term vision that we're working on.
Okay.
Yeah, I think a lot of people think that SQL Server Everywhere is just a small footprint database. Mm-hmm. Physically, that may be true, but really, what we need to look at it is why did we do it? What are we trying to enable? If you step back, a lot of the apps, typically the database apps, have been sort of client-server applications, where you have a big database server in the back end, and then you have a client, and you have some logic in the client. And a lot of times, if you want to write some very database-centric logic, you actually shove the logic into the database and then write stored procedures or triggers. So you actually put it into the database.
And the database becomes like this huge app server kind of thing.
Yeah, and database actually, a lot of people would argue saying the database can be app server also. But that's the way people build actual applications. However, in last 5 to 7 years, especially with the internet and then with the web, technologies, all the applications are becoming more and more multi-tiered applications. Mm-hmm. You might have heard the term service-oriented applications, SOA-based apps, and then architectures. And there actually the idea is that the world is distributed, so you can have data sources anywhere, mm-hmm. and then your logic can run anywhere, and then your client renderings are happening anywhere. Mm-hmm. So literally, the data and logic is everywhere now, because data can be in the back end, and that can actually move into your mid-tier, and you do some crunching, and then it may go actually into your the devices or the desktop, the clients. Mm-hmm. So in these architectures, what you really need is, if you look at the typical architecture, the application architecture, you have you have basically the presentation, and then you have your mid-tier logic, and then you have persistence. This is good in the multi-tiered applications where this is my database server, and then this is my app server, and this is my client. Well, these are all connected by some connectivity, whether it is HTTP or whether it is your dedicated lines, so you have connectivity. Mm-hmm. These all work well when you have always connectivity. What happens if I really want I'm on the plane and then I want the same app to run? Suddenly now you need to think about how do I do it in a disconnected environment. So we have started with the distributed environment. Now we need to support the disconnectedness also.
Sure.
There, I really want my client app logic as well as the persistence to be available close to me. Mm-hmm. So that means if I have my desktop, I actually wanted a laptop. I want all of those things to be there. That means I need my persistence available. I need my app logic available also. So that's paradigm shift.
Sure.
And then the third thing is app logic is, because app logic can be everywhere, and data actually starts moving to these app logic. Now we need to decide, do I put the logic inside the database, or should I really move data into the logic itself? The typical distributed service-oriented architecture where data is actually moving to the app. So this is sort of inverted from the traditional client-server mode where logic is sitting inside the database. Now the database is sitting actually inside the logic itself. This is called sort of the embedded databases, where I need to embed my database. What that means is my query processing and then transactions and then some persistence aspects of it right very close to my application itself. So that brings up another thing, called actually the embedded, the database issues. Finally, data itself, is not necessarily always stored somewhere in the store. It could be on the wire. In fact, I was told actually there's much more data on the wire than actually anywhere on the disk side. As the data is moving on the wire, I may want to really process that. Think of really your stock tickers. As the stock tickers are moving, they're moving actually per second. They're moving, and then I may want to really look at a window and then say, let me see, how stock changed actually in that window. You can't really take that and then shove it into a database and then do the processing. I need to bring my query processing to the stream itself.
Interesting.
Those kinds of things require different architectures than the traditional database architectures. So these things require, typically, I need to be able to embed my database in the logic, and the database needs to be small footprint. Because again, if I have a very large, server database, there's no way that I can actually put it into the application. It doesn't work. So I need to really have a very thin, very small footprint database. And it should be able to work both on in-memory data as well as disk data. Because sometimes my application may never persist any data, but I still need to process it. The scenario that I gave about the streams, it may never get persisted.
It's just this large amounts of data.
It's large amount of data flowing. It lives in memory for some time, and then I need to sniff it. I need to do something. I may figure out something, and then I may write it to a disk, but I'm not going to write the whole stream onto the database and then process it. So this requires actually in-memory data processing.
Okay.
And the other thing that we require is that, as you see, these applications, for a variety of reasons, for example, for failover, I may want to move this app from one box to another box. That means apps actually can move. They're portable. That means, along with the app, my database also needs to move. So the databases need to be highly portable. Portable in the sense that they should go wherever the app goes.
It's not even my app server to fail, but my device or my laptop.
Yeah.
I've been through a few laptops in my life, and you want to be able to move that app to the next laptop very easily without spending a week setting up all the installs and everything.
Yeah. So all of these things led us to really think about this, what we call the SQL Server Everywhere. And this is a small footprint database, and then I'll have Steve actually go into some of the details, what it supports. But essentially, this is very different way of looking at how you write applications, especially how you write data-centric applications, different than the typical client-server scenarios. They will continue to exist. We have SQL Server 2005, and then we'll have other server machines, and we'll have clusters, we'll have clouds, and those things exist. But to complement this, we also need highly moving distributed applications, and they are becoming more data-centric. And we need something like a SQL Server Everywhere, which embeds in that application.
Excellent.
And then it enables really cool, scenarios. I mean, think of really taking Outlook web access, is becoming a disconnected app where it runs even when it's not connected.
Right.
Already people are used to running Outlook in cached mode.
Sure.
But how about my OVA actually also runs in a cached mode? Well, in order to do that, I need some local store, sometimes even deployed inside the browser.
Right.
So it can't be really a big database, inside the browser. It has to be a very small footprint database. Yet I need to be able to support rich querying, and then good query processing technologies, and all of those things are still required.
Absolutely. Which, of course, we can discuss this in the implementation detail, but it does beg the question. I mean, SQL Server's processing engine and query engine and logic that they use is pretty incredible stuff. And I would imagine, how did you take that power and make it small? I mean, how can you make a small footprint for something like SQL?
Yeah. First of all, it is. We didn't really start from ground zero, because if the SQL Server Everywhere, if you look at the evolution, we have something called SQL CE.
Okay.
And that became, we called it SQL Mobile, in Yukon, the with-B time frame. And then SQL Mobile now, we are actually calling it SQL Server Everywhere.
Okay.
So this, when the focus really was on the devices, you have limited amount of memory and then limited amount of disk. So we needed to really come up with algorithms which apply to small footprint environment. So this is not taking really SQL Server as it existed and then chopping it. We started actually from the other direction, saying that given you have actually limited resources, limited restriction environment, how do we build a database? So you will make actually some compromises in, okay, the kind of query processing that I need to do, for example, query optimization, I will actually have more heuristics-based, simpler query optimizer. Whereas for server processing, I may do more thorough analysis of actually the queries and then the query plans, which requires more sophistication. Here we took simpler approaches. The transaction levels, it's the same thing. Even at the persistence level, everywhere we took approaches which are simpler, rather than actually trying to solve a very complex problem. And the data sizes are also limited. Here, you're not talking about terabytes of data. You're talking about smaller sizes.
And the number of users that are connected.
The number of users, exactly, or we don't need to support million user transactions.
Absolutely.
We're not running a TPCC benchmark or whatever. So the kind of really design choices that you make are different. I could write a small database, but I may not be able to use it actually on a very large OLTP scenario. But that's not what we are looking for.
Sure.
So these are different.
Like think with people using XML.
Yeah.
I mean, that's what they think about as their local database is XML, and all right, how do I write a query against XML, and how do I do transactions, and so it's a single user kind of scenario where they just have their local data. Think of it with Outlook as what
Sure.
your local data store, as opposed to the thousands of users that are concurrently throwing queries at this database. So that's the kind of difference of optimizations, what we can do with the Everywhere product compared to the server product. So it's a different type of query processing we're trying to do.
Understood. But I mean, you're still going to support the notion of stored procedures, and these are real transactions, right? They're real transactions. So I can be guaranteed they're either they're going to complete successfully, or they're not going to complete. So that kind of stuff that I'm used to as a database developer that I'm going to rely on. Now, as far as optimizations and the amazing stuff SQL is doing because of that, concurrent users. And now, let's for example, though, what if I have a pretty complex database model?
Before you go into that, I want to catch on
We
this.
touched on that one point that always comes up.
Yeah.
Okay, let's see.
You said stored procedures and transactions. Transactions, yes, so we do support the ACID properties where it is atomic, it is durable, and all of those things. When it comes to stored procedures, actually SQL Server Everywhere does not support stored procedures.
Okay.
And there is a reason for that. Is again, I started off by saying in the typical client server scenarios, so I have my client, and in the server you put the logic right here. Okay, I told you that I'm actually taking the database processing and then putting inside the logic.
Okay.
So typically stored procedure capture the logic, but this database actually, this SQL Server Everywhere is sitting right in the logic. Why do I need to write again separate stored procedures? Right. So this is my logic.
Okay.
I'm writing let's say I'm a document management system. I'm writing my checkout logic. Well, checkout happens to be this code that you pick your favorite programming language, whether it's C# or C++ or whatever you write it. Now, whenever you need to actually access the data, that you can actually write SQL queries and then access it.
Yeah.
But right now, in the server systems, the way you do it is you take the checkout logic and then you write it as a T-SQL stored proc and then actually run it inside the database. You don't need to do that.
Why would you limit yourself to T-SQL when you've got full managed code available to you? So this comes up a lot. There's no question this comes up. But the other thing is, if you think about SQL Everywhere, one of the main things is it's a code-free data file format. There's no code in the database. It's one of the few document types you could actually do in Outlook and open up the attachment and not worry about something evil happening to your machine. And so we want to maintain that purity and that simplicity of the data file format. And when the thing's embedded in your app, you have a much broader set of options available to you.
Understood. But I mean, so the database is embedded in your app, but you still have to have some sort of programming layer to interact with the database,
Sure.
right? So they're going to be SQL-like queries. So as a developer, I could use something like LINQ, right? If I wanted to
Absolutely.
write, for stuff that I understand as a general-purpose programmer, or I could write a bunch of strings that are going to be SQL
Right.
queries, right? Select star from blah, blah, blah,
Yeah.
where blah, between blah. So the only reason I had mentioned stored procedures was because what if I wanted to, like the way that you first outlined it was very interesting. The first thing that came to my mind was, wow, this is a smart client.
Yeah. Exactly.
So if I wanted to do my offline work and have it be the same thing as my online work, I'd want to have my database be similar to the one that, say, is on the server side where I am using stored procedures. And so bringing them down to the client would mean I wouldn't have to actually write the code again. That's all that I was referring to.
Yeah, I think so. What will happen is that first, if you're really looking at applications that are movable, across tiers, you would use less of the stored procs. And that's reality. Is already as you go into multi-tier architectures, where if you look at app servers, I'm writing a lot of C# code actually in my mid-tier, and you will. If you're looking for really something where I'm writing stored procs and then I need to really bring down stored procs, SQL Everywhere is not going to help you there.
Sure.
That
You
is
also
a
talk about
paradigm
the
shift.
evolving app model, right? It's just there's this app model that was written here where we had the this fully partition, physically separated kind of thing, and it's a pretty rigid architecture that a lot of people are having trouble with trying to deploy. Much less the end user saying, I just want my app to work.
Yeah.
If somebody trips over the network or the internet goes down, I can't afford to not be productive. So the architectures are changing to begin with. So it's not a matter of 100% fidelity. It's more a matter of how do we leverage these kind of architectures and have the right size footprints. Because there's no questions. There's lots of great features in SQL Server, but those are things that you want when this data rolls up to that central location. That's where you need those features. When you're talking about lightweight, apps.
So
Got it.
we looked at the upsizing part to work. That is, if you write a SQL Everywhere application, you can always move to SQL Server. Not all logic that is in SQL Server, you cannot bring it down.
Right.
So as you start really writing the applications, typically you have a local store and then you write something and then you may want to move up to this server. We'll enable that.
So the same.
So that's why we are a
data
subset.
types.
Yeah. So we are a subset of really what the SQL Server is, not everything.
Understood.
And this is an important design. Actually, I'm glad that you asked that question, but because it's an important design choice that we have to make, because we have to keep the footprint small. And for example, stored procs environment is very significant. It's writing a whole compiler, inside the SQL Server, and we didn't want to take that on. So those are the design choices made. And whether you use stored procs or not use stored procs, that's a religion. That's like app server guys and database guys have been fighting it for many years. So that will continue.
Yeah.
So I don't think, but I think our choices were it will enable lots of the application scenarios, not maybe every application scenario.
Sure. Now, you mentioned compilation, but do the queries get compiled? So they run faster the next time I run them?
Yeah, so that's the plan. All of those query caching, all of those things will continue.
Okay.
It's very basically the first time you run a SQL query, we actually generate you optimize it, and then you generate a query plan. And this query plan actually is in memory. The next time you execute it, for example, when you use the cursors or result set, you go get me next, get me next, get me next. It's already cached plan, so you're just executing it.
Excellent.
That model is very similar. And should we go into the architecture now, or should we want to really have a brief description of what SQL Everywhere?
Yeah, and I guess we could kind of maybe draw the picture because we made it. It kind of sounds a little bit like there's two models. I mean, the idea is we want to be able to take that architecture that Emil showed here and kind of explode and saying these are logical pieces. The physical deployment kind of has a different model. So I can take those pieces and this becomes my app, and it's got my UI, and it's got that logic and so forth. But you have lots of those distributed around, your company. So then what we need to be able to do is say, well, I don't want my data everywhere. So we need to figure out how do we roll that data up as well. So we still will have the central database solutions where we'll have SQL Server and where we'll have that with web servers to feed that over the internet and app servers and so forth. But we want to be able to leverage that both. So we'll have the ability to have that local data, have that logic, have that persistence, and then be able to synchronize that data or consume with services, architectures, so that it's not a different model. It's more of an extension of our current model.
Okay.
So that's kind of the big picture, and it's also obviously not just relational databases. We have files on disk that people store, and we're kind of embracing that whole overall architecture. How do we take this connected world that we seem to be living in and realize that connectivity is a very fragile thing? How do we leverage it where it's appropriate, but extend it to where users can work, on their terms, kind of any place, anywhere?
Yeah. I think in many ways, SQL Server Everywhere can act actually as your cache for your application. It happens to be local, persisted cache, and we can support transactions, we can support querying. So that's a richness that we can bring, as opposed to, today I have ASP.NET cache, but I can actually cache some things, but I don't have rich query right now. Well, if I actually can put SQL Server Everywhere there, I can actually give you, more things. We will get there eventually. Right now, we are enabling actually more the client-side scenarios.
Okay.
That's what we want to start. That's where we see a lot of value and in the pain points. On the server side and app servers, we see a value in the longer term. That's our bigger view, bigger vision. So we'll get there eventually.
Very interesting. I mean, that brings up an outstanding point to be able to use this technology on the middle tier.
Yeah.
Do really advanced caching as opposed to just not that ASP.NET caching is bad, but the other alternative that people use is they actually do SQL caching where they're actually going out to the SQL server. If you could get that, that's an excellent. But let's talk about usage scenarios. Just as a developer, if I'm designing an application, and I mean, you're a developer, you wrote the app, wrote a lot of this.
Right.
So, do I use this if I'm thinking I want to have an occasionally connected application? In other words, I don't use this to mirror something that I already written. I designed my application with this in mind from the beginning.
Yeah.
And I think these are going to be the usage scenarios for people.
Yeah, definitely. I think moving forward, that the lightweight database engine is perfect for your developer. It's as I'm building my application, I can pull my data out from any source, whether that's web services or directly from my database, cache it locally in this little database, and then present that to the user whether I'm connected to the internet or not. So it's just empowering the developer with a brand new set of scenarios that the device developer has been doing for years. They've always done replication scenarios, and they've always had to tackle these disconnected states. Whereas now we're just bringing it to the desktop, so it's very exciting.
That's very cool.
Actually, they have done a great job of, if you look at the Visual Studio experience, the way you develop your applications with SQL Server or actually the SQL Server Everywhere, it's the same. So you have similar experiences with, and that's a really cool thing is that you develop it, you can either deploy it actually on the device or actually on the desktops or the tablets or everywhere.
Really cool.
I really like that feature, that ability as a developer that you could be a device guy, you could be a desktop guy, and you could be a SQL Server guy, or you could be a SQL Server Everywhere guy, but the experience is the same. It's a set of scenarios where the developer is used to just picking their data source and the drag-drop gestures and the way to extend the ADO.NET model. It's a consistent experience that makes it very easy for a developer to go, I'm familiar with the desktop application, let me try build something for my phone. And you drop right into there, and it's just so great to be able to just go, I see that, I'm familiar with this, and boom, 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 together they build something.
That productivity was the key thing. I keep on hearing from customers, Microsoft's expanding at this exponential rate, and they're solving all these new problems, but I can't learn all this stuff. So, things are the same. Let me do it the same way. So whether it be device or desktop or the local store or remote store, I want a consistent experience with how I work with that. So just kind of interesting is the history of this. I mean, Kevin Collins actually used to drive a lot of these scenarios. And years ago, before he even joined Microsoft, he called me and he was saying, what if we took SQL CE at the time, going back to the history, and say we made that available on desktops also? And my first answer was, why wouldn't I just use MSDN? And we talked a little bit about it and talked about the things that Anil was saying. It was lightweight in proc and easy to just deploy and manage. So, oh yeah, that does sound great. So we've been working on it for a couple of years now, actually, and customers that have been using SQL CE and SQL Mobile said, hey, this is great. Why can't we just use it in more places? So in the Visual Studio 2005 timeframe in Whitby, we had been working on enabling this on more desktop scenarios. And we knew we were going to get there eventually. We just didn't know when. So Carlton, who was doing all the designer scenarios for devices, we just kind of kept on plugging at it, and I kept on logging bugs and just kind of like secretly kind of just kept on making the scenarios work. And we didn't quite get it done in the main proper Whitby time frame, but that's why we're able to make those experience work now, is because we were doing it all through Whitby. Just kind of this little skunkworks kind of thing, and I'd log a bug, and Carl's like, "Oh, I'll fix that. Don't worry about it." And we have the experiences we have now within the product. So really, all we needed to do was take SQL Mobile, take this license restriction out that we had, and now we could work on desktop scenarios as well. So along the way, we decided to change the name as well. So it kind of threw a little wrench in the works for us, but it really recognizes the idea that wherever your data is, you'll be able to use a SQL Server product. And it's just, Paul was, Foster was talking about this data explosion. The idea that there's going to be this one monolithic data store in the world, much less a company, much less a user's environment, is just becoming unrealistic. So the idea is, how do we extend and embrace the fact that data is everywhere, and not force them into JET or XML or an Excel spreadsheet or something, but let them put it in a real relational data store that once it's in there, and we've got these same basic data types, and you got a consistent programming model, that now we could help IT, help end users be productive, and then roll that data up into a central store where now you can start doing things like business intelligence and understanding what are those data that's doing out in the field, how does that affect my company? So we can bring that up, look at it with some of the business intelligence products, and managers and VPs can start getting visibility into what exactly is happening in their company. So that's kind of the model.
Well, one thing you touched on that I really like is that because the data types is a subset, it makes the retargeting scenario so easy. It's just switch out a connection string from hitting my backend SQL Server to my SQL Server Everywhere database, and you're pretty much done. There's only a few tweaks we need to do with if there was a data type that isn't supported on SQL Everywhere, but all in all, it's a really great experience, and that's, I think, one of the hidden powers that will come out soon.
Very cool.
Yeah, I actually see there's two standard scenarios that people will use it. The low-end developers want a small store, which is part of their application. They'll use it. And the other one is like the ISVs who really want to, you don't even know that there is a database. So they can actually embed the database, but it's their database, but all you're interacting with is the app. And so there'll be scenarios where ISV applications will ship the database as part of their application. And actually I said two, but the third one is really the client-side caching, the offline scenarios. It'll enable, I have something there, but I really want to bring subset of the data here. I want to have it locally, and I want to have it disconnected mode, or maybe occasionally connected mode. I want to really operate on it. It could be any app. It could be your financial app, or it could be your manufacturing app. It could be any of it. It can cross all sorts of vertical domains. But I see that's the paradigm that, those are the scenarios that will enable.
Cool. Now, one of the important things, of course, is syncing.
Yeah.
So is there a syncing mechanism in this, so it makes it easy for me to sync with the central store?
That's kind of fun. We
expert.
So one of the first things we hear is from people is people are trying to get all their data centralized. So as soon as they're trying to get rid of all these JET and Excel data stores and so forth, and as soon as you say, well, we're going to embrace the fact that data is everywhere and enable users, God forbid, that you go, well, okay, it's fine, but how do I now roll that up and synchronize it to get into those BI kind of scenarios? So there's a couple of things that we have. We actually have merge replication, which we have today, which is an awesome technology, which allows you to replicate the schema and the data from the central server down to the local database. And of course, bidirectionally, so I can create data, edit data, delete data locally, and push it back up, and so forth.
Yeah, so between SQL Everywhere and SQL Server, we support merge repl.
And always have,
Yeah.
right? It's always actually been in support even over HTTP protocols, where so it's always been enabling it out to the field. Now, what we also get from users is going, hey, I love SQL Server. If given a choice, that would certainly be my choice. But we have this legacy system, or somebody else made the decision, and we've got Oracle or Sybase or DB2 or something else in their company. Or that this merge replication is feature rich as it is, I don't need all that power, and it's a little complicated to set up for some users. So within the SQL Server Everywhere store, we actually have this other lightweight technology called RDA, Remote Data Access, not RDO. And Remote Data Access is a really nice lightweight sync model that allows me to execute a query against the server, take the results, put it in, directly stuffs in the local database, and now I can kind of party on that data locally. Either the list of states and I don't want to track changes, or I want to create orders or newspaper delivery routes or whatever, and then occasionally kind of push the changes back up. So RDA is another technology we have that's unique to SQL Server Everywhere, which has been in SQL Mobile and SQL CE. But the problem that we have is that RDA is almost too lightweight for many scenarios, and merge replication is almost too heavyweight for many scenarios. And we constantly hear from developers going, hey, I've got data sets, and I've got ADO, and I got XML, and these web services. It just seems easy. Why can't I just do this sync model myself? I'm a developer. I can figure this out. And while that's true, they quickly trip on a lot of the problems that we have with conflict detection, synchronization, transactions, and all these things, and persistence and local. So what we've done is, we're building on that going forward. So today, you can use RDA and merge replication. What we're doing in the Orcus timeframe as we ship Visual Studio Orcus, and two next releases out of SQL Server Everywhere. So SQL Server Everywhere will be shipping later this fall. And then in the Orcus timeframe, next year in 2007, we'll be shipping the Orcus product. That in that timeframe, we're going to ship these new set of sync components that are based on ADO.NET. So if you're an ADO.NET programmer, you're going to be very familiar to it. Instead of having data adapters, you'll have something called sync adapters. You'll have a sync agent, and you'll be able to do the client-side tracking in SQL Server Everywhere, and you'll be able to deploy these other components on the server and synchronize between the two. So you don't have to have all the intimate knowledge of your database on the local client. You'll be able to do it on the server. I can probably just draw a picture of it just as easily here.
Great.
Yeah, I'll try to leverage this model we have here. So on the client, we'll have your local SQL database, and you got your app. And then on the server, I could have an IIS box. So I'll draw like the full N-tier kind of model here. And I could have all this kind of logic running here. And what you have is, if you think of your form, we'll do the typical data grid, data bound to some data in there. Mm-hmm. And there can be some amount of logic that's in there as well. That's kind of the programming model the developer can do, because it keeps it kind of simple, right? I got my entire app. But what they can do now is use these new set of sync components that can synchronize this local data through a service proxy. So think of this as just some kind of proxy that you can put on web services or WCF. And it can talk over here to this guy, and here is your service exposure. And then it can unload that package, that payload, and now it's actually in a payload, and we're actually using the dataset API because it's the one API that everybody's kind of familiar with. But I'll talk about that. And now you can perform logic on this data and validate it, and you can use link and use whatever kind of logic you want to perform on it. And then you pass it back to it, and then it can then use these sync adapters, which will know how to execute the commands against the database. So, data adapters have select, insert, update, delete. Mm-hmm. Sync adapters have some additional commands like select incremental insert, select incremental deletes, select incremental updates. So it's the same basic model. Now, what's interesting about this is while we'll have all this for SQL Server, if you notice, these components, they're very much this provider kind of model. Is if I wanted to do RSS or I wanted to do some other blob format that I decide, you can write your own proxy and you could talk to my.com, whatever, and synchronize those as well. So we'll have a model that works from end to end that you can plug into. It's a very componentized model.
Interesting.
I think if you take like a real concrete scenario, if I take a CRM application where I'm the sales guy, I go and then create lots of my contacts offline. And we give you primitives now saying that, what changed since yesterday? Or you can actually go and then ask saying, tell me, since I really synced with my headquarters, what changed? So I get the changes back as a data set. Now, I can go sniff that and then say, oh, this looks good. Or maybe I may remove a few things or I may add some things at that point. It's up to you. The control is given to the app. Now I'll say, let me go and then apply those changes to the database. Right. So now I say there is an apply API and then say, apply these changes. It goes here. Now, typically in a service-oriented architecture, I never trust anything, which is coming from anywhere but within my domain. So now here I can actually have some other validation logic which says that, I got all the data set. Let me look through this now, revalidate all my contacts, and then make sure everything is good. Then I can say, now, apply these changes here. So we give you control to the application. At the same time, we can actually give you building blocks so that writing actually sync becomes easier. Getting change tracking, actually applying the changes, detecting conflicts, and then resolving conflict. We give you building blocks. Now you can actually stitch the end-to-end sync the way you want it. That's really very powerful.
Very nice. So you're basically providing an interface and let people party on it.
Well, it's like these raw components. And we've had this product called Merge Replication, and again, people love, but when they need to get in and dial a few things, it was very difficult for them. And then we had ADO with commands and connections that are just almost too low level. So that's what we've done is we've just taken that programming model and extended it up. And it's going to continue. I mean, like I said, we have link features that are available in here because it's just data. And then with the entity work that's happening, that you can kind of abstract out your customer who might be represented as multiple tables, or an order. You think of an order, you don't really think of an order header, order items table. You think of it's an order. So going forward, we'll be able to sync at that level as well. But this is kind of where we're starting, so we want to get this out and get feedback from customers and enable people today, and we'll continue to build on this model that just kind of extends out the data that works in remote areas.
Cool. So just where do devs get their hands on this stuff?
Actually, before you go into that, I just want to add one thing. Here is a good point to sort of architecturally, as you pointed out, the flexibility in the sync component. The same thing even for the database. We made it very componentized. If you look at typical. So you have the storage engine, and then you have the query processor, and then you have the APIs. To the typical databases, it's a big monolith. So you can't really get. If I want to really get to storage engine, there's no way you cannot get to it. The way SQL Everywhere is componentized is there's lots of time people just want to use an ISAM engine. If you look at AD, which uses JET, it primarily uses actually key-based access, and then it's an ISAM engine. It doesn't really need actually a query processor. I have one, why can't I just expose that? So we do expose that. So we expose actually just the storage engine APIs. Or if you want really SQL query processing, and we support both ADO.NET as well as OLEDB interfaces. And we have the sync component, as we talked about. The sync component itself, as Steve described, it is componentized so that you get the agents and then the sync providers, all of that stuff. We can dive deeper into that. So what is SQL Everywhere? It's really a collection of components. It's literally it's a collection of, 6 or 7 DLLs.
Sure.
And depending on your needs, you just pick only the storage engine DLL. I don't need everything else.
But
that is
the
okay.
total, but the whole thing totaled together is still
Yeah.
less than it would fit on a floppy.
Yeah.
So it's kind of, you look at it going, yeah, I only need certain parts of it, but at the end of the day, right now, I mean, we're a total of 1.4 megs for the whole thing. So it's sometimes easier to just grab the whole thing and grab. But as we extend things, so if you're using these new sync components but not merge replication, or you're using merge replication but not this new sync components, we'll make sure we have a factored model. So it will grow. There's no
Sure.
question that a thing will grow. We will definitely not grow to the size of the server, because the server is trying to solve a bigger problem. But Neil's point is we want to keep it very componentized, so you can pick and choose the amount of functionality you need to keep
Which
it
is-
very
Clearly,
lightweight.
the apps are not going to. There's so much variety in differences in the app. One size does not fit all.
Precisely.
And here, the componentization, and sometimes we need to support extensibility, where somebody wants to write, actually, hey, I want to write my own query processor on top of this. Go do it, because we expose
Excellent.
these APIs. You go do it yourself.
Sure.
Yeah.
I'm not going to stop you from doing that.
Excellent. I mean, that's the
So that's-
beauty of componentization.
Yeah.
Now, is that componentization model, your architecture, clearly you got, you were well advanced in that because you came from the world where you have to componentize things,
Yeah.
namely CE and
Yes.
devices.
In fact, it's really interesting. On the devices, there are certain apps, they just use only the what we call the EDB. We used to call it EDB, which is basically the storage engine.
Okay.
They didn't want all of these things,
Sure.
and we had to already do that. And there are slightly sophisticated apps. They said, I wish we had just a little bit of SQL query processing, so we gave that.
Client scenarios like MSN client,
Yeah,
Media
so
Center
there's-
PC.
Yeah.
This is why when we say we're releasing SQL Everywhere on desktop, this isn't a V1 product. This is the third major release between CE Mobile and SQL Everywhere. But we also have already been using the engine on desktop scenarios in products. So even our own product teams, we're using components of the app to package with their app as a lightweight data store.
Yeah.
So that's pretty cool.
That's very cool. Now, so you mentioned it's composed of 6 or 7 DLLs. You want to draw a little picture about what?
Well, that was pretty.
Yeah, that's
pretty up there.
actually, we can even show that one.
Yeah, and I guess
If you-
Cool.
if you-
show it right on.
Yeah.
We've got the picture here kind of shows it, but if I actually looked on disk on where once it's installed, if we go to see program files, Microsoft, SQL Server, everywhere, the all 7 DLLs of the native runtime, 1.37 meg, and if we bring in the managed provider, I'm just trying to get the file size over here. There's another 227. That's just the managed provider for it. So we actually have a really light runtime that you can easily deploy, with your app. And up on my blog, I actually have some videos of programming against SQL Server Everywhere, and even our deployment options. So one of the things that we had to do in SQL Server Everywhere to install on desktops is we never actually had an MSI. You had no way to actually install the product on the desktop. We had it for devices. So we had to actually go and create an MSI that just installs the storage engine on your machine. But we also heard from customers is it's great, I can get this MSI and deploy it on my machine. But as we're talking about, when it's embedded with my app, I don't want a separate MSI. I want it to ship with my app. So you can actually take those DLLs and ship it as part of your app as well. And that's one of the
And
core
then you can
scenarios.
Sure,
do
that's-
once deployment.
Yeah, you can do quick once deployment of this as
Nice.
well. So
The Xcopy scenario is fantastic. The ability to take an application, throw in 5 files, 7 files, that's the database engine, your database file, and give it to somebody on a floppy disk or a USB key and play with it. It's just amazing. That model is something that users find really hard to come by these days, and for us to ship it with SQL Everywhere, it makes the deployment model so much easier.
Fantastic.
The click once is also something that was new for SP1. It wasn't something that we had time to do in Visual Studio 2005. But if you get the SP1 of Visual Studio 2005, it's now right in there when you click to publish your application. SQL Server Everywhere shows up, the prerequisites are checked, and so that deployment over the web is just as easy as it is with SQL Express.
So actually,
Do
just
you want to show that? Or?
I could show it, but I could, for the sake of time, it's up to you. Sure, let's just do that. So I've got Visual Studio here, and I'll create a new project. And nothing new here. We'll bring up the data sources window, and now I can choose database just as I would choose for the server, and bring up the normal connections that I've got here. But what I'll do is I'll change the connection type. And remember, it was SQL Mobile, so in Visual Studio 2005, you choose SQL Mobile. You now get the connection dialog specific for mobile, which becomes everywhere. And if you click Browse, we actually ship a sample Northwind database with the product, and the default location will bring you right to it.
Mm-hmm.
So now, and I could quickly test the connection, and it comes up that quick. There's no instances to spin up. It just runs in proc. So I can then click through, and I'll say, yeah, it's the Visual Studio is saying, hey, this data file is outside. Do you want to put it in your app? Well, yeah, because that's the whole point. Is the database is part of my app. So copy the file in. Notice it brought in Northwind SDF to it.
Mm-hmm.
Save the connection string in a settings file. And then I can do, the typical, I'll just grab employees, for instance, and bring that into my project. So now in this case, to have consistency, we actually have a strongly typed data set. So you have a consistent programming model. But it's not the only programming model. Of course, you can still use ADO and so forth. So I could come over here, and I could make this, individual controls, and we'll just make that a label, right? Because you don't change your primary key and all that stuff. And I'll drop it on my form. So other than changing to SQL Mobile as my local store, which the experience was exactly the same, like Carlton was saying.
Nice.
So now if I want to click once deploy it, we have two models. We have the model with click once where it can install the MSI, that if I go to publish, what I can do is under prerequisites, if you install the extra XML files that we ship as part of the CTP, you'll get this option right here to deploy it right from, just put it as a prereq. So now there's one other thing that we have to do is under settings is notice that because it's a file, it's a relative path, it says /.
Mm-hmm.
So in click once scenarios, we have this whole model where the data is one directory and your app is another directory. So it has to resolve, well, where is my data directory? So one of the things that we added to the SQL Everywhere build since SQL Mobile is we added something called data directory support. So if I put in this pipe, data directory pipe, what we call a macro, is the runtime will resolve where that data directory is and then find our SDF. So now, at this point, I can just easily publish this app to my machine, and Visual Studio will build up the app, build up the prereq, and now I'll have that all set up, and when my end users clicked on the link, they'll actually get this dialog that'll come up, or the web page that'll bring up here, and they can click once and then install it. So notice it says, hey, the framework is required and SQL Server Everywhere. Mm-hmm. So if I click install, it'll run the little setup checker, and because it's already installed, it just runs. Mm-hmm. If it wasn't installed, it would run a quick little dialog that says, hey, do you want to install SQL Server Everywhere? So now it's saying, hey, do you want the app? Well, sure, I'll take the app. And bang, I now have my app very easily deployed. So that's the MSI deployment model. Mm-hmm. Now, what we also have is the option that says, I don't want to deploy it with my app. I don't want to deploy SQL Everywhere as a separate MSI. I want to deploy SQL Everywhere as part of my app. Mm-hmm. So I can come back over to Publish. I'll uncheck the prereq for SQL Server Everywhere. And now what I can do is take those 7 DLLs, drag them right into my project, select them, and I will say copy to output directory if newer. So as Visual Studio does a build, it makes sure those DLLs are in the the bin directory of the app. Mm-hmm. And the other thing I have to do is the managed reference is currently, because on my machine it's gacked, it says copy local is false. Mm-hmm. So that ADO provider isn't actually copied in my bin directory. If I toggle that to true, Now when Visual Studio builds, and if I look in my bin directory,
You'll have the file there.
I'll see all those files are actually there.
Mm-hmm.
Let me hit refresh here. So here's the native DLLs, and here's the managed provider. So now, if I click once publish this again, am I okay? Sometimes you wonder where the publish icon went. That's interesting. Okay, let's
You
do
just
plan
show-
B. I don't know, that's kind of funny. All right, so
Maybe
so much for live television.
Very good.
Publish now.
There
So
you go.
it'll now publish the app, and because I said don't make it as part of a prereq,
Mm-hmm. You don't run an MSI.
right? So it'll just copy the DLLs.
Great.
Yeah.
Okay.
Hold on. You got to recover from the broken demo here. So we'll just
Yeah, but that
we'll show how
demos are
Visual
meant to be
Studio does
broken.
load very quickly there, and we'll republish it. And there we go, publish.
Great.
Bugs in software, you gotta love it. And so now we'll publish, and this time because it's not a prereq, I just have the DLLs as part of my app. That my install will be, no prereqs. I can non-admin deploy this on a machine, and say there's no prereqs listed. So it'll just, install my app, and it'll just run. And now SQL Server
That's great.
Everywhere is shipped with my app.
That's fantastic.
So.
Yeah, the non-admin scenario is really interesting. I think it really gives people in a lot of business development the ability to send out apps and not worry about restrictions on the machines
Yeah.
and all those issues about deploying the app.
Cool. Now, you mentioned the term CTP, so you guys are in CTP mode?
Yeah, so we
That's
kind
customer
of
technical preview.
yeah. So we have new buzzwords these days. So CTP is generally something that's not necessarily RTM quality or it hasn't had a lot of testing. In this case, CTP probably was not the best word we could have used because it is the SQL mobile product that we already have a lot of confidence. We've already shipped it, and all we did was create an MSI, add this data directory macro. And some other bug fixes that we rolled into the service packs. It really is as close to an RTM product as we can possibly think. We were waiting a little bit because we created this MSI and we wanted to get some integration with the Visual Studio tools, as Carlton was talking about.
Also
Service
with
Pack
the
1.
SQL Server Management Studio.
Right, SQL Server Management Studio. We want to
Yeah.
raise up the visibility of SQL Server Everywhere so you can work with it within Visual Studio and SQL Server Management Studio. That we're just taking a little time to make sure if there's any other bugs that we can fix and not have yet another service pack for it. So if you go to Microsoft.com/Sql/Everywhere, there's a link on the right that you can get to get the CTP. What I showed you is when we install it on the machine, we copy those DLLs and we register the managed provider in the global assembly cache. That's it. There's no system 32 changes or anything.
Sure.
No services are running. So the impact to your machine is absolutely minimal. So when we say CTP, I wouldn't say that people have to go off and worry about installing a VPC and running it in that.
Absolutely.
You're more than capable of putting it on your production laptop and using it. And on that webpage we have the MSI, which the developer can put on his machine. And once it's on his machine, he could then take those DLLs and publish them with his app, or take the Click Once Bootstrapper packages that are on that page also, and then Click Once the app to their end users as well.
Now, the main differences between CTP and then RTW are the branding changes.
Okay.
Really.
Yeah.
Like we used to call it SQL Mobile. Now we are calling it SQL Server Everywhere because
Okay.
we wanted it to be branding. And
Understood.
that does require some integration with VS and then SSMS Management Studio. But otherwise, the runtime is really third release product. So
We seem to be taking a lot of time just to do a branding change, is what people are telling us. And branding has localization effects and all those other things, documentation.
Plus it's also you need to wait for all the other product. You need some ship vehicle along with that.
Yeah.
So we expect later in this year, along with Yukon is going to have an SP2 and then with SP1 and then so we think that there will be a nice release vehicle along with those things also.
So basically, we're waiting for everybody else to catch up with us.
But we will have web downloads. That's why I think we have the web downloads. Even
Yeah.
moving forward, we can be more nimble and then do more web downloads.
Sure.
There will be some runtime changes. We'll keep enhancements, but we don't have to wait for other things to ship. I think we can ship more frequently.
So now, what ties you to Visual Studio 2005?
Well, so
Why do I have to have WIDBE framework on my machine?
right. So well, the WIDBE framework. There's a difference
Not-
between Visual
not
Studio and 2000 and
That's
the
what I meant.
framework.
Okay.
So the framework gives you the managed programming model. But as Anil said, there's a native programming model as well that you can use. But if you want to program with ADO.NET, that's where you need the framework 2.0 to get productivity from it. Now Visual Studio gives you all the tool support that we just showed.
Of course.
So all that designer support that we're doing, and some of the two workarounds that I showed there, where you had to manually go and check the prereq for SQL Server Everywhere, or manually put in the data directory macro. Those we didn't do in 2005. When the Service Pack 1 ships for Visual Studio, those two things will be automatic.
Got it.
As soon as you add an SDF file to your project, we'll automatically check the prereq for SQL Server Everywhere, and we'll automatically create that data directory macro for you, so we won't have to do those extra steps.
Understood.
And in all the places that says SQL Mobile, it'll say SQL Server Everywhere as well.
Understood. But as long as you have, like you were mentioning earlier, if I don't care about, for some reason I don't want to be really productive and don't really want to use WIDBE, let's just pretend, I could still use this technology
Yeah, you
on
can.
1.1 framework.
Oh, no, well, the 1.1 framework, we actually didn't have the managed providers on desktop
Oh.
scenario.
Okay.
So all of this stuff is kind of 2.0 framework kind of stuff. So hopefully
Right
this
on.
is a good reason for people to go to 2.0.
Oh, absolutely. One of many.
But one of the key points is, while today the scenarios don't work in the Express product of Visual Studio, it's more around the designer support. So we didn't have SQL. SQL Mobile actually was shipped with the Visual Studio for Devices extensions.
Okay.
So those things aren't in the Express products, the Visual Studio Express products. But if you wanted to bring the runtime down, you could bring a reference to it and code on it, directly, just writing just straight code.
Sure.
But in the Orcas timeframe, the Express products will have SQL Server Everywhere as part of its core as well.
Fantastic. Well, this is great stuff. We're running out of tape, but it's funny how these conversations just could go on and on and on. Where can people give feedback to this stuff? I mean, it is a
I just write the two
CTP.
blogs.
Yeah.
there.
Yeah, blogs.
So I'll do it actually up here. Yeah. So blogs.msdn.com/ you can go to my blog, and I've got a lot of information up there about Q&A.
Okay.
We also, the actual SQL Server Everywhere team
Mhm.
has got a new blog they've set up called SQL Server Everywhere.
Got it.
So there's lots of information up there. We've got some videos that I've posted, some of the things that I've shown there, some individual breakouts, and then you can certainly send, there's links to send us feedback at either one of these blogs. And we'd love to hear about the scenarios people are doing with SQL Server Everywhere. I've heard some really cool things, and go from there. Oh, and of course, at Microsoft.com/SQL/
Everywhere. That's where the CTP.
that's where you can get the
Sure.
I'll get out of the way. And that's where you can actually get the SQL Server.
Microsoft.com.
Well, yeah, I guess they MS. It's not MS.com. Microsoft.com. I guess I'm hoping
Microsoft.com.
people are listening.
These are developers out there.
Yeah, I think they
They're
kind of know
pretty
where
smart.
Microsoft.com is at this point.
Very cool. Well, hey, thank you for your time.
Oh, thank you. It's
Thanks for coming by.
Great job, man. And, thanks for
Thank
spending
you.
time with
Yeah,
us, Anil.
that's fun. Yeah.
All right. Great stuff.
See you next time.